Hi.
Hello?
Hi, are you able to hear me?
Yeah, I can hear you. Can you hear me?
Great. Okay. Yeah, I can hear you too.
Cool.
Great. So welcome to this interview, mock interview. Um,
Cool.
Let me just get started with a brief introduction about myself.
Sure.
I have 10 plus years of experience working in the industry, of which in the past 6 years I've been in the Bay Area, and before that I was in India. Of late, I'm working for a media company in the Bay Area, and I've been a backend engineer throughout, working on Java and related technologies. Yeah, that's about me. Why don't you tell me briefly about yourself?
Sure. I've been working in the tech industry for just past 1 year and just joined
Mm-hmm.
the company after school. And
Mm-hmm.
I've been working on those DevOps automations, so using
Mm-hmm.
Python and
Mm-hmm.
to automate the tasks so that we can reduce the human errors and also just save some time.
Got it.
Yeah,
Got
that's
it.
about it.
Sounds good. Sounds good.
Cool.
Great. So the way the interview would work is we would dig deeper into this coding question.
Sure.
Typically, I will allocate 45 minutes, around 45 minutes for the question, and beyond that, we'll stop and we'll go through the feedback, if any. I'll also be documenting some of this feedback, so that should be available to you on the portal of interviewing.io.
Okay.
Um,
Cool.
okay, and in between, if we have some audio issues, then I think we can jump onto a phone call. I think they give us an option to connect with the PIN code, so we'll look out for that in case we run into that, because I run into in the previous interviews that I've taken
Oh, okay.
sometimes. So yeah, just giving you a heads up so that we know what to do when if
Okay.
at all we run into that.
I see.
Okay, and so great. Any questions so far?
No, I think that's about it. Yeah.
Perfect. So, have you worked on this environment before, the interviewing IO coding environment?
Yeah, I've done a couple of them, and
Oh, perfect. Okay.
right.
Okay. So, pick a language of your choice,
Can I use
and
Python?
then yeah, sure. Feel free to
Okay.
use any language.
Okay. I'll switch to Python 3 right now,
Yeah,
and
sure. So I will just type in the question.
sure.
Uh, Yeah, so this is the question for you. I think three
Okay.
quotes is comment, right?
I'm sorry. What's that?
Is this a comment? I mean, is this comments in Python? The three quotes,
Yeah. 3 quotes is a
right?
mountain line comment. Yeah, it's good.
Right. Yeah. Okay.
Yeah.
Perfect. Yeah. I
Cool.
don't remember that. Yeah. Perfect.
Yeah, it's like in Java, it's doing like this, but similar
I know.
thing.
Yes. 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 Yes.
Yeah.
Exactly. Exactly. Yeah.
Okay. I see.
Hmm.
Cool. And given array z 0, 1, 3 now the colors are not the same binary value. Oh, interesting. If it's possible, return any. Okay, I see. In the first part and second part and the third part. Okay, all three parts have equal binary value. Okay, I see. So it's an array with only 0 and 1s, and it's a list. Okay, I see. Uh, so let me just get the function's footprint going.
Yeah. Sure.
So maybe divide array input. So basically, the input will be like an array of zeros and ones. Okay. Output. So basically, output is going to be the index, right? Indexes of the tool.
Yes.
These are the tool pivot. And so is it possible like the array is actually less than length of 3? So it's like 0 and 1, so we couldn't find any. And we should just return
Yeah, those are
0
edge cases. Yeah, those are edge cases. Yeah,
for
you
minus 1,
can
minus
consider.
1.
You can now right now assume that it will be more than 3.
Oh, okay.
Three or more. 3 or more. The length
3
would
or
be 3
more.
or more. Yeah.
Okay, I see.
Mm-hmm. Mm-hmm.
More. So, for example, like example 1, 1, no, 1, no, 1, and we can split at 0. 0 should be inclusive. Okay, so it's gonna be from 0 to 1, 1 to 3. Okay, and I see. So it's actually found each one is equal to 1. I see. Okay. Yeah, I think just like thinking out loud, we can just have like a 1 point, like it's gonna be 2 indexes. So I will have
Mm-hmm.
like 2 pointers. Like
Mm-hmm.
first one will be the starting point. The second one will be like maybe the end point. I haven't decided yet, but it's gonna be like it's gonna be after the first one.
Mm-hmm.
So we can like swipe the like check each starting point.
Mm-hmm.
Like for example, the first one, so it's gonna be I and J.
Mm-hmm.
So for 1, 0, 1, 0, 1, the
Mm-hmm.
first like I will be here, and maybe
Mm-hmm.
J inclusive. So I will say J here.
Mm-hmm.
So the first one is 1, the second one right now is 0, and the third one is 1 and 1. And okay, we can just like for each I, we can check the rest of the J,
Mm-hmm.
and if like the value of I is equal to J,
Mm-hmm.
we can continue. We can like check if the J, like the rest of the value are actually
Okay.
um,
The third part is
like
same or not?
right, something like that.
Okay. Okay. So
Uh,
what would be the time complexity in this case?
it's gonna be like 1, 2, like assuming we have n of
Mm-hmm.
elements, and for each one we're gonna swipe n times, and we're gonna check for each j we're gonna check n, like n minus 1 basically. And so it's n square. Um, I think 1, 2, 3. So j is like a swiping, and we need to. Yeah, but we have to calculate the value, so it's gonna be like swipe the rest of the array as well. So I think it's, I mean, it could be like n cube.
It could be n cube.
Like, cause like for I, we're swiping from 0 to all the way to like n minus 2, and for J,
Mm-hmm.
we're swiping from like 1 to n minus 1, and for each J, we're actually checking the rest of the value, and I mean, assuming like there's no patterns in this array, and we're just checking one by one. Like worst case, it's gonna be, I think it's gonna be, because for checking the third
How?
value,
Mm-hmm.
like
Mm-hmm.
it's gonna be, you have to loop through the rest of the array, and you're actually doing multiple times. So I think it's worst case will be n square, like
Mm-hmm.
I'm sorry, n cube, because
Okay.
yeah.
Okay. Okay.
But
So.
I'm thinking out loud right now because I'm kind of seeing like multiple duplicate calculations, right? Because you're calculating 0, 1, 0, 1, and then
Mm-hmm.
you're calculating 1, 0, 1. You just keep doing the same calculation multiple times. Maybe we can do
Yeah.
some
Mm-hmm.
like pre-processing,
Mm-hmm.
and so that we don't need to calculate all the time. And yeah, that's
Okay.
what I'm thinking right now. So basically, for pre-processing. Pre-processing. So I will have like and maybe I would say nums front, something like I'm checking from the front, and so nums front I means from 0 to I, and like equals to the integer of its representation of its array, right? Input I. So it's gonna be like 1 and or 1 0. So it's gonna be like 3 basically. So we're gonna calculate each one. And yeah, I mean, during the pre-processing, we can optimize that by like ×2 and plus the like the digits, because we are moving 1 digit further.
Okay. How much of advantage would you achieve using this pre-processing? Like, what would be the value add to your complexity?
Value to my complexity. So I think it's gonna be reduced to n cube, because for each time we are checking I and j, it's actually just it's like indexing. So we can call this num front to get from 0 to I, how many, like the integer of the representation of.
So how much would it be?
Like swiping n and plus you can check each one. So I think it can be reduced to n cube.
But you did mention that initially it was n cube, right?
No, I'm sorry. I mean, initially it was n cube, but right now we are trying to reduce to n squared, so n to the power of 2.
Okay.
Yeah.
Okay.
I mean, swiping I and swiping j.
Okay. Okay, that's fine. Now let's get back to the examples, right?
Okay.
Before we jump into this, like with the pre-processing.
Sure.
What do you observe about the zeros and the ones in each partition? The number of zeros or the relevance of the number of ones in each partition, and how about the zeros to the left or the right in each partition?
In each partition? Oh, I'm sorry. I'm trying to understand your question.
In the example 1, can you write me the 3 partitions?
Example 1, right?
Yeah.
Okay. Yeah. So it'll be 0 to 0, so it's 1, and then it's gonna be 1 to 3, so it's 0, 1, and then it's gonna be 3 to the end, so it's gonna be 0, 0 and 1. So that's gonna be the partition. And yeah, I think that's the partition.
Okay. So what do you see about what? Right. So what do you see about in this particular example? What do you see about the relevance of number of ones in each partition?
Oh, I see. It's actually each of them has only one.
Okay.
Oh, okay.
And what about zeros? Like the relevance of, is there a relevance of number of zeros? And if so, does it matter if it is on the left of the leftmost one or the right of the rightmost one?
It doesn't matter on the leftmost, but it does matter on the right side, because that's gonna advance 1 more digit. So for example, 110 will be actually 3. Oh, I'm sorry. 110 is actually 2. 0, 1, 2.
Right. So if you're
to the power of 1, and plus the 0 times power to the power of 0. So
Yeah, so if your example was this, each of the partition would be 1 0 1 0 1 0, right?
right, exactly.
Okay. So, and also, so using all these observations, can you figure out what the partition should look like, what the rough idea or rough indices of the I and J would be?
Oh, okay. I see what you're saying. Oh, you mean I and J? So what's the partition of the I and J? What
Yeah.
should be? So, so I start from here and J from here. I, J. Okay. So are we trying to like optimize the process of calculating each integers?
So
I'm trying to get
yeah,
the.
so I want you to think. So right now what you've done is you're jumped into a solution. You're trying to optimize the solution that
Oh,
you
okay.
initially proposed. I want you to look at the problem and think in a different direction,
Oh, okay.
so
Yeah,
that you come up
so.
with an even better algorithm.
Oh, okay. So right now we are like based on the pre-processing approach, right? We are trying to get each.
Yeah, I want
Oh,
you to come out of that solution. So we'll get into it if we are running short on time. Let's spend the next probably 5 more minutes into
oh, okay.
thinking whether we can optimize on looking at the examples, right?
Oh, okay.
What do the examples tell you about? What are the relevance of ones, zeros? And can you figure out in linear time a solution?
Oh, okay. I see. Yeah, I think it's actually so if you move like from I to J,
Hmm.
if the J is moving like to the right, it's actually getting bigger.
No, I don't want you to worry about. So that is
Oh,
your
okay.
initial solution, right? I don't want you to think about it. I want you
Okay.
to come out of it and think about what is the relevance of zeros and ones, leading
Okay.
zeros, trailing zeros, the number of ones. Can you find out I and J without doing the iteration at all,
Can I
based on
find
zeros
a?
and ones?
Okay.
Can you find the I and J
Oh,
directly
okay.
without going through two loops, nested loops?
Oh, okay. J without going nested loops. Okay. I think so for each I, and we have some value, then we just need to find. Oh, okay. So for example, if I is actually stopped at the second position,
Mm-hmm.
like I is like 1 0, so we know I is actually, so J we can starting from the next one, and then we can count. Oh, okay. Count how many, like, so am I getting close? Like if it's 1 0, and for J, we can just get the next one because the middle part doesn't matter. That's actually the trading, like the starting zeros. So for I is actually the same because like the I has to be start from 0. Otherwise, it doesn't matter. It's gonna be 0.
Mm-hmm.
So I starting from 1.
So what are your breakpoints for your I and J right now? Like how many ones should each of these partitions have? Can they have different number of ones?
No, they can't. They have to have like the same ones and.
Right. So
Yeah.
So till when would you go to find I and J?
For example, for I right now I have 1 0.
Take a
I'm
complex
gonna.
example. Take a complex example wherein there are a
Okay.
lot more ones and zeros, because you are stuck to this basic example and you're not able to think beyond that.
Oh, okay. So maybe we can get another example.
Mm-hmm.
1, 1, like 0, 1, 0, 0, 1, 1, 0, something like this.
Mm-hmm.
And so starting from here, so I equals to 1,
Mm-hmm.
and J is actually equals to 1. So right now I and J
No,
are
forget
actually. Oh, okay.
forget about I and J right now. How many ones are
Okay.
there?
Mm,
How many ones are there in your example?
right now it's 6.
So how many per partition?
Oh, okay. So I have to make sure, like, oh, I see what I'm saying. Finally, yeah. So I have 6 ones. So each one has to be had 2, and I'm gonna
And how
check
many
the
zeros? How many zeros to the right of the rightmost one?
to the right of the most one. 1, 2, 3, 4, 4 zeros. Oh, you mean that in this list
In
there's
each
only
partition.
in this partition. This partition there is only one. I mean the last one is the after the last
Exactly.
one.
So you can deterministically find out how many zeros to the right of the rightmost one are required from the last partition, right?
From the last, yeah, right.
Okay.
Because
So now
we
you
cannot get
know
rid of this 0.
exactly.
'Cause-
So now
okay,
can
I
you
see what I'm
find the
saying.
I and J? You have all the information that you need to find I and J now.
Oh, okay. I think what you're
You,
saying
you
is actually, so from the left we have to check the first one, and from the right we have to check the like zeros, because those are the things we cannot get rid of. Um,
mm-hmm.
like these are starting from 1, but like all the way. So no matter where is J, it has to be end with 0. And okay. So basically, okay. So we can count how many ones we have, and so uh, if it's like a odd number of um, like if there are 7 of ones, and you cannot evenly split those 7 ones to 3 partitions, we can return -1, right? Because we
Right.
because they
Right.
couldn't be equal. I see.
That's right. So what if there are 6, and what do you do if there are 6?
So I mean, so basically, we just oops, check how many ones, like and check ones and see if it goes to 0. And if it's not, just return -1, because we couldn't get anything. So once, and we can then split them to each has ones. So each one has like for example, if it's 6, each one have 2 of ones. And then we can, starting from the left, get 2 ones, and like so, and it's possible that we can stop until next one. Then starting from right, get 2 ones,
Mm-hmm.
and we can actually stop until next one, so that we don't like affect our. Oh, okay. So basically, so it's gonna be, we can check for each side how many different combinations we have. But I think like from that part, oh, okay. The only thing, so from this left part, it's actually only affecting the left value. Like different I, because until we see the next one, it's gonna affecting our left value, but doesn't affect our middle value, because the trading zero will be like, doesn't matter. And from right, we're gonna see, oh, okay, and we're gonna like shrink from both sides and check that. Okay, I see. So like, let me figure out what the stop condition, because at some point we need to return the indexes. And
So, but where are the zeros coming into picture here?
where does the zeros?
You're not taking into consideration the zeros, right?
No, I mean,
In
like
line.
for the step 3, I'm stopping until I see the next one. So like this could be 0, like it could be multiple zeros in the middle, and that's gonna be like the loop, like how many 0 I can have, and it's gonna be affecting my.
Oh, okay. So I think we'll need some more time to discuss on this further. So in the interest of time, why don't we go ahead and implement the earlier algorithm that you proposed, wherein you have the pre-processing and you find out all the permutations, because this will take some more time and I want you to code something for me.
Oh, okay.
Yeah.
I see.
Yeah. Make sense?
Sure.
Because this is
Yeah.
you are missing out a few points over here, and we might spend another 5-10 minutes on it. I don't want that to happen, and you running
Okay.
short of time to implement something, right? So let's do the initial.
Okay. I think like, are we getting close? Because I think the idea, your like recommendation is very good. I mean, we're actually, each step is actually
Yes,
makes
but
sense.
you are not actually taking into consideration the zeros to the right of zero and utilizing that to make informed decision in the loop itself. Right now you will be generating more permutations. You'll have to check like how many zeros to the right of the rightmost one in each partition should you be adding, and then check for the values.
Okay. So basically, like the step 3 and 4, those are multiple zeros. We're gonna loop.
Yeah, so you shouldn't be doing, I mean, that's not required basically, because you are not utilizing on some of the observations that you have pointed out.
Okay.
Well,
like,
okay, so I'll leave the addition to you. Do you want to continue analyzing this further, or do you want to code? It's up to you.
maybe we can like quickly discuss this, because I think the
Okay,
approach
fine.
makes sense to me. It's really nice
Fine.
approach.
Okay, so you mentioned that the the third partition,
Okay.
from the third partition you can figure out how many zeros to the right of the rightmost one are required,
Right.
right? How are you using that information?
Are required. Oh, okay. I see what you're saying. Yeah. Oh, okay. So I can actually check the left one, the left partition, because it can't be less than that, and it has to be more than the. Well, yes, I think it has to be equal to the number of zeros trading the left partition. So for example, we have, so for example, here we have 1, 0, and the last, we have only 1, 0. So from the left partition, I have to starting from 1, 1, 0, because I have to have 1, 0. Because the third partition is going to have 1, 0 anyway. I mean, it's going to have 1, 0, and so we will start from the 1, 0. So basically, we are reducing some permutations. Like we're trying to decide the end of the left partition, so that it has the same trading zeros as the last partition. Am I understanding correctly? Like for the line 28, it's 1, 1, 0. It couldn't be 1, 1 because the last one I have the 1, 0 at the end. So the third partition is gonna have a 1 trading. So I need to make sure.
How about the second partition?
The second partition will starting from the first one. It sees. So I think we can just like check in the middle and what's the value. So basically, we want to make sure like left and right they are actually equal.
So do you think checking on the equality is a good thing to do, or do you think so? First thing is finding the INJ.
Okay.
Finding the only. So can there be multiple solutions to this? Let's try to answer that.
Can we have multiple solutions to this? Multiple solutions. I think we are splitting different. So the amount of ones we know for sure, and we just need to check how many trading zeros each one have, and how many trading zeros each one have. I think it should, because I couldn't think of multiple solution right now. I will say it's like one solution.
Okay. So assuming that there's only one solution, right?
Okay.
Now, just a minute. Hold on. Okay.
Okay.
Right. Just a minute. Yep. Hey.
Okay.
Still there, right? Yeah. So assuming that there's only one solution, right? So can you find out the INJ in that case, and then do the equality check later?
Okay, I see. Yeah.
So finding the partition is one thing, and then checking if all the partitions are same is the second problem.
Okay. Yeah.
So that way you don't need to complicate probably your code.
Okay. So like find the INJ, then check quality. Okay. Yeah. So find INJ, I think we're pretty much almost there because we check how many ones we have. And so that's gonna give us the exactly I. And so we from right, we can check how many ones we have, and that's gonna give us how many zero is required. So that I can move my I. If I can move my I without like, I mean, like if I can have my I satisfy this required zero, then I can compare. If I cannot, it's gonna return like -1, -1.
Okay. That is the first partition. How about the second partition?
The second partition, you mean the middle partition, right?
Yeah.
So the middle partition, since we already decided how many ones for each partition have, and we will check from the end of the second partition, which is J, and we can see if it's actually can be have the required 0.
Okay.
Like same as the INJ.
Okay.
Like for example, the line 28, there's only 1, and we're gonna check if it's possible to have the last 1. Last 0, only 1 0 after the rightmost 1, and if it has, then we can like continue check for each check the equality.
Okay.
So
does that yeah, I mean, I think that might work. It depends on how you're coding for these things. But what would be the time complexity now?
The time complexity will be like from left and from right. Then I'm just checking one. Okay, I think that's gonna be all of linear, because at most we're gonna check only like each one is gonna check once.
Okay. So let's get started with the coding. We have 12 minutes, so let's see how much we can progress. Yeah.
Sure. Let's try to implement that. Okay. So the first one, I will find how many ones, count of ones, count of one. Like for edge cases, I think it's this one, and cannot be if cannot be equally split, then just return -1. Okay, now we have kind of ones will be, and for zeros we can like require zeros equals to maybe starting from 1. I think we can check from the right, like check J first. I set up some pointers. I equals to 1 0, J equals to then. Oh, input is actually a keyword. Maybe I just put array so that I don't confuse. J is the last one. I think it's in the middle. There's gonna be a M, but we can decide later. So let's say required. Let's say cur ones 0, while J so if array J equals to 1. In Python, it's actually a Boolean. So if array J, we can J minus equal. That means equal. J equals to 1. We can reduce this They, this will give us the valid, like the required ones. Okay, so what if 1 is equals to 0? Okay, that could be, there's no ones. Okay, that's actually a kind of a special case. Because if there's no 1, we can actually return anything. Once to 0, just return maybe. For this case, it's actually, it could be multiple solutions because that's always 0. And that's kind of an edge case.
That's an edge case, yeah.
Yeah, okay.
You can return any random thing, that's fine.
Oh, okay. I see. Yeah, I can return 0 and 1. Okay, right now we are here. So checking the J pointer. So J minus 1. Let's think. Let me think if it's gonna. I think it's gonna be finding the 1 anyway. It's not gonna fail, right? Because we already count how many ones, and it should find the last point, like require 1 position. Okay. Current y equals to 0. Okay. So I think this one right now we have J. Oh, we have to count how many like required zeros. Oh, I need to like stop it. Oh, okay. So if like curl ones equals to 0. Let's see. I'm checking once, and if it's 1, I'm gonna plus 1. If it's not 1, means it's 0. If it's 0, and right now we don't have any ones, we're gonna check. We're gonna say required zeros is actually plus 1, so that we can also get the required zeros. Let's see. All right. So now we have J, and we also have required zeros. Okay, let's find the I equal to X. Y has to less than J. Once. I can call once 0. Clear. And yeah, let's say coins plus require zeros. Once require zeros. It's less than that, so it's gonna stop when it reaches that. So what if it's okay? And stop it. Okay. So if array I equals to 1, then we're gonna curl once plus 1, and if require zeros. How do I know how many zeros? have any zeros. Equals to required zeros. Yeah, I think the better name it will be required ones, but if it's less than that, zeros less than required zeros. Zero will be +1. What if it's actually equal? So it's gonna break off condition. And, so if it cannot found, we should just return -1. How do I decide that? So I is less than j. I think that's gonna be for sure. And cur1 is cur0s. Let's see, maybe some special case. Cur1 is equals to 1, 0, 0, and 1, 0, 0. Okay, that's actually equal. So I need to make sure. Okay, if cur1s no, I think that's not correct. We should check ones only. We don't need to check the sorry, I'm taking a little bit long time here. So I'm checking ones only. I don't want to check 0. So I need to find the I. So y I equals not j and cur1 equals otherwise. Okay. So right now cur1s is actually equals to, I can check how many zeros should I get. While I still is gonna be equals to j. I'm gonna check zeros. Right now I actually already advanced one more pointer. So I could be 0. Cur0s. And if I is actually equals to 0, and cur0s +1. So I keep looking at if it's not equals to 0, actually I should break. You're still seeing 1. Okay, I think it's gonna break the loop because I already found enough 0. But still there's a 1, 0. And it's gonna break. And that's actually so I'm gonna check if I less than required zeros. I'm gonna return edge cases because I couldn't find any required zeros. It's not gonna be equal. So right now I have my I actually equals to, should be I minus 1 if it's inclusive. Let me double check. ij such that I plus 1. So I will be included in the first part. Okay. So right now I can check equality, right? Because I only find the I and j. So far, are we still good? I think we are running out of time, but
Yeah, I'm just looking at this. So you have found the I and J.
right.
Okay, why don't you print? So before going to equality, why don't you run this for to print I and J and
Oh,
just
okay.
check?
Yeah.
Yeah, let's do that, right? I mean, we can
That's actually
figure
a
out.
good idea. Yeah, that's a good idea. So divide, like for example, it's a pretty basic example. 10101. And we're gonna run it. 1, 3. So it's to return 1 and 3. Yeah, because I think I is gonna be the previous one, because you actually found the it's gonna be maybe like this. Yeah, because I is actually the starting point of the middle part. So if you ever say middle I, something like this. So the middle starting point will be I. And so that
Okay,
we
let's take another example. Add a zero to the
sure.
end.
What's that? Oh, okay.
Add a zero to the end.
This one, right?
Mm-hmm.
And that's 1 and 3. So it's gonna be 0, 1, and 0, 1, 2, 3. Okay, J actually. Oh, J is actually the same. It's yeah.
No, then the first one will break, right?
What do you mean first one will be break?
This one will break, right? The first example would break.
Oh, okay.
If you try to fix it that way.
So
Anyway,
Jay, I'm trying.
so I think we are just left with 5 minutes. So I think we should stop here because the real interview would stop 5 minutes before this, right?
Oh,
So
okay.
I think so you're on the right path, but I think you need to there's somewhere in the whole logic you are missing out things. We'll have to sit and debug. We'll have to print out those values and figure out like what those values are at that point in time. But I don't think so by increasing or decreasing the count it will fix the issue. It's in the conditions when you're going through it, somewhere out there in the condition. Cool. So let's spend the next 5 minutes probably going through the question and the feedback, basically, right? So what did you think about the question?
Oh, you mean this question?
Yeah.
I think it's a really good question. I've never seen this before, but it's really a good question to me.
Okay.
Because I can literally see how much time I can save by actually like analyze the characteristics of zeros and ones, like the binary
Exactly.
integers.
So
Yeah,
that
from
was a
left and
very
from
big,
right.
exactly. So that was the biggest flaw in this whole question, in this whole interview for you. So the thing is,
Right.
there are two ways to approach your problem, right? So one is trying to understand what the question is about, what are the different examples, what are the
Right.
relevance of the values given in these examples, right? And especially
Right.
when you are cornered with array or a kind of example with limited set of or type of values, we should definitely focus on what are the relevance of these parts in the example or in the question, right? So that is one way to one approach to solve the problem. The other approach is, of course, of trying to optimize your code, right? You came up with a brute force algorithm. You're trying to put in dynamic programming, pre-processing logic, and trying to optimize your code actually. So what I feel is, like, generally many candidates do this mistake, like they, instead of looking at the problem, like it's always good to start looking at the problem and then trying to solve for the kind of peculiar cases that may exist in the problem, and then moving on to uh, your code optimization, because that's like after you code, you optimize the code, right, to work more performantly. So I think so this question is a mix of both. So you once you figure out the relevance of zeros and ones, then it comes down to how you are coding. That's why I mentioned when you were about to code that it depends on how you are expressing your conditions. Like it's all about like finding the number of zeros that are required in each partition at the right, then finding out the number of ones that are required in each partition, and trying to adjust the I and j based on the number of ones and the zeros to the right. This will give you the three partitions, and in the next, once you get the I and j, you get out of the loop and then you do a equality check, right? So this would be the pseudocode or the algorithm basically for solving this problem. Now it depends on how you are putting your conditions, where you are putting your conditions, and finding that ij. So that is the crux of the problem, finding the I and j. Then equality check is like easy part to do, right? So spend more time into understanding what the question is about and how you can utilize the nuances in the question, like the different using different examples. You were reluctant to take examples. That was another thing, right? I think you were stuck with that given example. You're stuck with the when I'm giving you hints saying that what is the relevance of the number of ones, you should immediately have gone to, like, it should be a multiple of 3, because there are 3 partitions. It has to be multiple of 3 basically, right? So if it's not a multiple of 3, you cannot split into 3 partitions. And if it is a multiple of 3, then whatever the quotient is, like if it is 2, then it is 2 per partition. So can I stop there? Can I just point my I and j to where 2 ones are? I encounter 2 ones. The answer would be no, because zeros have a relevance. And the leading zeros, which is the leftmost zeros, don't have any relevance. The rightmost zeros have relevance. How would you accommodate that in your I and j? So so the thing is, if I think the more problems you solve, the more you will think in this manner, right? So this is a smooth transition of thought process, right? One after the other. So I think it's just a matter of practice, and it's just a matter of due diligence. Like whenever you come across a question, instead of trying to come up with a brute force and trying to optimize that brute force, try to think more about the problem, like so that the interviewer also might give you more hints, etc., and you might be better successful in solving the problem in that case.
Yeah, thank you so much for your hints, and also these feedback. These are really helpful.
Sure, definitely. And I have added a few annotations in the whole interview. I think these will be visible to you. But I think these were few things that I noted, and I hope that it helps you in some way.
All right, thank you so much. Yeah, I will take a look at this, and I will solve this problem later after this we're done this interview.
Sounds good. Yeah, I wish you all the best.
And thank you so much for your time.
Yeah, sure. Bye.
All right.